Welcome to the Center of Math Problem of the Week. For this week's problem, we want to find all positive prime numbers, all pairs PQ that satisfy p to the fifth plus p cubed plus 2 equals q squared minus q. So we're going to do a little bit of algebra first. So we just subtracted 2 and factored both sides. So we have p cubed times p squared plus 1 equals q minus 2 times q plus 1. So note, q minus 2 plus 3 is q plus 1, so the only possible common factor between these two is 3. So we're going to consider cases where they do have a common factor of 3 and where they don't. So first, let's assume they do have a common factor of 3. So that means 3 divides q minus 2 and 3 divides q plus 1. So since p is a prime, so p will be either congruent to 0 modulo 3 or 1 or 2 modulo 3. So if it's congruent to 1 or 2, p squared is going to be congruent to 1. And so this will not be divisible by 3, and same p will not be divisible by 3. So we have p must be congruent to 0 modulo 3. But since p is prime, this is only possible when p in fact equals 3. So from this, we quickly get p must equal 3. Plug that in, we'll see q must equal 17 here for these two to be equal, and that's one solution, 3, 17. So note that, so first we have, now we're saying the case these two are relatively prime to each other, 3 does not divide them, and nothing else can divide both of them. So now, looking at p cubed must divide them and must either divide q minus 2 or q plus 1. So note p cubed must in fact divide q plus 1, because if it divided q minus 2, the maximum possible value of q plus 1 would be p squared plus 1, which is going to be strictly less than p cubed, which is impossible since q plus 1 is greater than q minus 2. So we have p cubed must divide q plus 1. So now we can write q plus 1 as k times p cubed, where k is some additional factor, possibly greater than 1, but we want to show it can't, in fact, be greater than 1. So q plus 1, that's q minus 2 plus 3. Now q minus 2 must just be p squared plus 1 over k, since q plus 1 times q minus 2 equals p cubed times p squared plus 1. Plus 3, so we have plus 3 there. But then we can note that p cubed, kp cubed equals p squared plus 1 over k plus 3 is in fact impossible for k greater than 1. So k must equal 1. So we're left with p cubed equals p squared plus 4, and so p must equal 2 and q must equal 7, and that's another solution, 2, 7. So our solutions are 2, 7 and 3, 17. Thanks for watching. Please check out centerofmath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.